On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this session on Ubiquitous Security, a new paradigm for security in Industry 4.0. The session is organized under the aegis of Industry 4.0 Expert Committee, chaired by Mr. A.N. Chandramouli, who is our past president and who is also the MD of ANC Consultants. The Chamber acknowledges the support of Mr. Sajid Mustafa, who is the Executive Director, Crossview Technology Solutions, for accepting our invitation to address at this session. The Chamber acknowledges the support of the members who have sponsored the events annually: Bueller, Fundermax, Wipro, MTR, and Sona Group of Colleges. May I now request Mr. A.N. Chandramouli, our past president, and who is also the keynote speaker of this session, to take it over from here. Over to you, sir.
Thank you. Thank you. Thank you. Welcome to all of you. Let me now share a small file. Rupa, are you able to see my slide? Mustafa?
Yes, sir.
Good morning, one and all. More people are joining, but let me give some few introductory remarks for the day. In our series of webinars on Industry 4.0, with primary focus on manufacturing sector, we've been handling many topics, both technology related and application related topics. But a topic which covers all the topics, which is an overarching impact on all the domain inputs of Industry 4.0, is a cyber security. And security is the biggest concern when it comes to IT related programs and projects and technology. And Mr. Sajid Mustafa, Executive Director of Crossview Technology Solution, has kindly agreed to address the gathering and share his knowledge and experience and the various projects he has done. A brief profile of Mr. Mustafa. He has been a business and technology executive with more than 21 years of industry experience across multiple verticals and functions, which include IT services, collaborative innovation, IoT, industrial IoT, M2M connectivity, edutech, telecom, government, public sector, intelligent transportation solutions, logistics, healthcare, medical equipment ecosystem, business delivery, and strategic operations, to mention a few. He has an extensive experience in helping clients as well as organizations to nurture and drive internal innovation and digital transformation journey. Syed, his core expertise is to manage P&L, plan and optimize right products. So he is very careful in looking at the return on investment feasibility for his projects on digital transformation. And he has got a whole host of experience, including competitive landscape mapping, stakeholder satisfaction score, UI, UX, features, partners, pricing, monitoring life cycle of products, partner acquisition, content development, technology teams working toward business goals, monitoring effectiveness, remodel to maximize return on investment, with specific focus on collaborative innovation, that means together with the customer, and continuous improvement objectives. In his career, he worked in Logica, which is part of CGI, which is a famous Canadian company. And that's about Syed. And thank you, Syed, for accepting our invitation. And the key takeaways, I hope my third slide is visible to all. The key takeaways or objectives of today's session is, number one is Mustafa will explain the need for securing hyper-connected systems in the context of Industry 4.0. It is not cyber security only for individual equipments. It is for the entire connected enterprise. And as opposed to ERP system security, we will look at the Industry 4.0 systems for cyber security. And you will identify the gaps between conventional IT/OT frameworks, IT being the information technology, OT being the operation technology, and the structures thereof. And we will try to understand the macro strategy to achieve what he calls as ubiquitous security. I don't know what is ubiquitous security. Mr. Mustafa will be the right person to explain that. I know the English word ubiquitous could mean many things to many people. It could mean omnipresent in one sense. Let me understand from him also when he presents. And very briefly, the three things are elaborated here. Industry 4.0 involves an hyper-connected system automation and cyber physical systems. The two pillars of Industry 4.0 being automation and cyber physical systems to effectively and efficiently manage manufacturing systems. And with the use of all the technological systems, it is imperative to ensure cyber security. It plays a big role in the rise of digital industrial revolution. And last but not least, is the entire industry becomes very vulnerable through the hyper-connected systems and security lapses as compared to a traditional enterprise system design like ERP, etc. So with those few remarks from my side, I will stop sharing and request the mic to be handed over to Mr. Mustafa. I will see whether my stop sharing is working. Yeah, I think my stop sharing is working. More people are joining and 15 people now. We will see. It always happens on a Saturday morning. People are very tired of the week. And now it's 11:15. Mr. Mustafa will take his course up to 12:30. And all of you, welcome to add questions on the chat box, clarifications, appreciations on the chat box. From time to time, our speaker will could intervene and answer some of the questions. We have a lot of time today. And around 12:30, we will start taking some questions which are left unanswered. And even I have some doubts. If it is not covered by the session, I will ask that. And since it's a small group today, any of you can raise your hand and ask question at the end after 12:30. Before that, you put it in the chat box. Thank you, and over to Mr. Mustafa.
Thank you, Mr. Mowli. Very good morning to all of you. Very much appreciate the honor of sharing some, thoughts and experiences in this August gathering. And that was a very remarkable introduction that you gave for me. I myself wouldn't have been able to introduce myself so well. So
thank you
again. Once again, thank you. I'll start sharing, and just a few pointers in the beginning that I have kept it as generic and as fundamental as possible, because I didn't know the composition of the audience. So there might be some of us here today who are already experts in the field, whereas there might be some of us who are very new to the field. So I have designed and tailored the content for the newer people to get the fundamentals onwards. So that is one pointer that I wanted to share. And security is a continuously evolving field, and there is a lot of work happening. So what I'm presenting today is basically acquired knowledge of work done by various entities. So in my presentation at the end, I've also cited the references that I have used, the data points, the codes that I'll be using, and the case studies that have been put out have been referenced. So that is also there. I'll start sharing, and just let me know if you can see the screen. Is it visible?
Yes, sir.
Yes.
Okay. The slideshow is visible, right? Okay, thanks. So I'll proceed now. Now, the term ubiquitous security, right, is nothing but a derivative or something that is led from relative terms which are used in the industry, primarily being ubiquitous computing and ubiquitous manufacturing. So this is the term that we are starting to now apply to security within this ubiquitous environment. Now, before we get into that, we should always try to understand how it started, how this journey has started, and we'll take it up with understanding the evolution, right? So whenever we think about evolution, this is the image that actually comes up. I don't know where this image has come from. And for decades, we have been seeing this image in multiple contexts, different topics. The image is same the moment we say evolution. But we won't be focusing on this image. Rather, today's focus would be on this image, right? So the evolution of computing. Before we understand the security, the threats that have been offered, we have to understand the field to which this is applying, right? So if we see the evolution of computing from the 70s onwards, the typical early computers were large mainframes, right? So there was no actual computing power at the user level. It was all centralized in a mainframe. And the user just had a terminal. So there was nothing much that could be done from a terminal because it was just an input-output unit. Slowly, the journey began, and towards more personal devices in the midst. So 90s and 2000s were more about personal computers, where computing was happening more on a local mode rather than something which was central or away from the user. And then as internet came, it started going towards web and then mobile, and then finally it has gone into cloud. So it started with very centralized computing, and then it has gone into a very decentralized computing from a cloud perspective. But if we look at it from an evolutionary point of view, this has not been a very linear evolution. Rather, it has been a very non-linear evolution. So there have been various offshoots that have taken place across time zones and technologies. And if you look at it this way, so you see, there was one path, which is kind of the predominant path of computing, which went from mainframe towards cloud computing and edge computing. But in between, there was also a path that went towards peer-to-peer. Now, if you have, if you remember, I think about a decade back, there was this huge buzz around torrents. There was a lot of content being downloaded through torrents. There were a lot of clients which were being developed and sold, BitTorrent, MuTorrent. And I think the major use of this was to download pirated content. But the underlying technology behind it was a peer-to-peer technology. So it was, computers talking directly to each other in a serverless mechanism. But again, because of the lack of security, there was an increased incidence of malware being introduced, viruses being introduced. So that whole technology kind of died down because it could not sustain in the long term. Whereas on the other hand, cloud computing picked up, right? So you can see similar times, P2P and cloud came in, but cloud has now reached a peak and it is now evolving further, whereas P2P has kind of died down. So this is how typically, the computing evolution has happened. Now, when we talk about cloud computing, there are terminologies which are interchangeably used. That is pervasive computing and ubiquitous computing. So pervasive computing is, again, unless we get into the minutiae of technical definitions, they can be interchangeably used because it's prevalent all across. Like when we talk about ubiquitous computing, computing is happening everywhere. We have a very strong and a very powerful processor, a very powerful computer in our pocket, our mobile phone. Now, if we look at it from a different perspective, there is a very nice analogy that the amount of processing that was used to land a man on moon was 100,000 times lesser than what a typical iPhone has. So you can imagine we are carrying 100,000 times more processing in our pockets today than what was used to land a man on moon in 69. Right? That is the kind of relative measure of computing power that is available today. And also, along with that, the same amount of computing power is available at threat actors to penetrate and break the security defenses of any system. A small look at the evolution of security, or rather the security threats itself, right? So I don't know how many of you know which was the first act of a security breach as a ransomware. I'm the chat boxes here, or my apologies, I'm very new to Teams. I'm more of a Zoom person. So yeah. Right.
What is the question?
So sorry.
What is the question?
Does anyone knows which was the first act of a security breach through a ransomware?
Year 2000?
Sorry?
Year 2000?
No, it was much before that. So basically, ransomware is a kind of a program that lodges itself into your device and then locks you out till you pay a ransom to the actor who's caused that incident. So that is why it's called ransomware. Now, this happened in 1989, right? That was the first ransomware incident that was reported, and it was done by a doctor, Dr. Joseph Pop. And what he did was he put up ransomware onto floppy disks and distributed this at a WHO conference on AIDS. So the title of the disk was AIDS Information Introductory Diskettes. And he distributed to everyone. People took it home. And how this worked was that once the floppy disk was put into the computer, the ransomware got lodged, and it didn't work immediately. So it counted. So 90 times the system was rebooted. On the 90th time, this Trojan, it hit the directories and encrypted all the names of the files on the computer. And then to regain access, the user was expected to pay $189 to a shell corporation that was set up by this person as ransom to get back the thing. So this was the first known attack of a security breach through a malware into a computer. And over the years, these attacks have become more and more sophisticated. Like the years, the decade of 90 to 2000 was the decade of personal computers. Windows was doing a lot of development in that time, from Windows 3.1 to 95, 98, Millennium Edition. And most of these threats were around Windows systems, because Windows, from a security perspective, was a very vulnerable operating system as compared to Unix-based operating systems. And at the same time, email also came in. So there were a lot of email threats that were happening, virus being sent through emails and so on and so forth. And then the decade of the 2000 to 2010 was more about web, websites, .coms, e-commerce coming out. So this is when, the web vulnerabilities started getting exploited. And more, information was getting stolen from the web through phishing, through stolen credentials, and such things. And of course, now this current, trend is around DOS. DOS is the denial of service. It's something similar to ransomware, but then it is again, denial of service. It could be for ransom, or it could be without a ransom. So you have a lot of these ways of attacks that are happening, and the trend that is happening. Now, if you see the trend of the attacks and the sophistication required by the actors, like in the beginning, someone needed to be a really expert in computer programming to be able to hack into a system or cause a security incident. Whereas over time, that requirement is coming down because more and more advanced tools are available, which can be used by actors to break into systems. So if you look at this graph, it clearly shows how the availability of technology and tools is getting higher, and the knowledge required from the actors is coming down with time. So now anyone can become a hacker. So that is a very scary scenario where anyone without deep knowledge also can just pick up some tools and start doing it. And this has led to this term called hacktivism. Is anyone aware of this term called hacktivism? So hacktivism is basically activists, activists who are doing something for a social cause, who are supposed to be good people. Now, an example could be environmental activists, right? So environmental activists, on one side, you have got these protests that happen and all these things, but on the other side, they hack into companies or organizations who they perceive to be damaging the environment. And even though the intention is good, the act is not good. The act is not correct. It is wrong. But that's the reason they are called hacktivists. So they are hackers who are activists, and they don't want a ransom. Their main intention is to shut down the operation or disrupt the processes of that organization. And with this, what happens is their need to know the depth of the technology to do it goes down and down. They can easily get some tools and deploy those and do this kind of stuff. So this was about the the trend of technology versus skills. And if we also take a look at cyber threats from a technology perspective, right? So technology evolution over the years has been more and more pervasive. This is where I use the term pervasive because if we look at the technology evolution, we start from data in silos to internet, which is more public availability of data. To we get the mobility solutions in place where 24/7. See, internet was not a 24/7 thing, but with mobility, now we are having 24/7 access to technology. At the same time, the potential of getting a security breach also becomes 24/7. And as we get into the newer technologies and as we move into the future, right, our devices are also undergoing a change. From handheld, now we are becoming ubiquitous, like wearable technology. Now, wearable technology makes it all around us. If we put on a VR glass, everything around us is hackable, right? The IoT brings in drones are a major cause of concern because a drone can be hacked and made to cause a lot of damage and destruction. One more very important thing that is happening now is the use of federated identity to access government services. And this is happening worldwide. For example, in our country, the use of Aadhaar. Now, the use of Aadhaar today, from birth certificate to life certificate, it is used across all the service spheres. Now, even though we know for sure that the UIDI is very secure and the entire concept of holding the data is very secure, there have been incidents where service providers who use the UIDI data have been breached, right? So there have been such incidents. So the underlying thing over here is that we need to keep secure protocols everywhere all the time, whereas the actor just needs one pinpoint of the threat surface to gain access and cause disruption. So that is the unbalanced struggle that as security professionals or as organizations, we need to fight in terms of maintaining security of our systems. Now, these are some facts. Now, when we say security incidents, some of these might be there in memory, but many of these have happened and are very serious and very, significant. But they have not gone down the public memory so much as something else related to celebrities or something. For example, anyone knows Stuxnet? Have you heard of Stuxnet? The Stuxnet incident? Okay, I'm looking in the chat, so no. So okay, so Stuxnet, I think can be termed, if I'm not mistaken, as the first incident of a cyber attack being used as a weapon. So in 2009, Stuxnet is the malware that was used to attack a nuclear enrichment plant, which caused the centrifuges to spin out of control, right? Now, this was introduced via a flash drive, but then it autonomously spread across all the production networks of that nuclear enrichment plant, and it caused a lot of this, disruption to their things. So the sophistication of this attack was kind of an eye-opener to understand how cyber attacks can be used even as weapons. Right now, probably cyber attacks have become more common in our news as different ways of disrupting different things. But Stuxnet was probably the first time this was used to attack a state facility. Another example, if you see here, you have a lot of public services as well as a lot of well-known products. Like, for example, Tesla's remote hack. The Tesla's S model. There was a remote hack done on that to just show the vulnerabilities that are there in autonomous cars. Persirai botnet is an example. Philips was a much more worrying example, wherein the security researchers, they actually flew a drone outside the building where the Philips Hue smart light bulbs were installed, and then they could set off a virus-like chain reaction that jumped from bulb to bulb and controlled the entire network to which these devices were connected. Right. So these are some of the incidents that have happened, which show how important it is to understand security in this ever-increasing hyper-connected world, where everything from power grids to highways, everything is dependent on interconnected devices. And when we talk about today's focus, that is Industry 4.0, and how security is to be applied, or what is the macro strategy of security for Industry 4.0. So this is the small journey which I'm sure most of you would be aware of, because you are all from that industry, right? So these are the different industrial revolutions, starting from pre-industrial revolution to the first, second, third, and fourth, and how Industry 4.0 heralds a new age of connected, smart manufacturing, responsive supply networks, and tailored products and services. Now, how it does this is it's through use of autonomous technologies. Industry 4.0 is trying to bring together the digital world with a physical action to drive these smart factories and enable advanced manufacturing. So essentially, we are talking about digital and physical coming together in the Industry 4.0. Now, how that happens is we take a look at this cycle, right? So the technologies that enable digital manufacturing and a digital supply network involve integration of digital information from various sources, right, to drive physical manufacturing and distribution. Now, this integration of IT and OT is marked by a shift towards a physical to digital to physical connection. Now, the Industry 4.0 is crucial in this, that it combines the IoT and relevant physical and digital technologies, including analytics, additive manufacturing, robotics, high performance computing, AI, cognitive technologies, augmented reality, all these things to complete that cycle and digitize the entire business operation, right? So what it does is it takes the physical data from sensors, from different actuators and devices that are there in the factory or the organization, and then it digitizes that. It creates a digital record of that, takes it to a place where it is analyzed and visualization is done. And then algorithms get applied to this to generate some decision making, to generate some decisions, which are then again applied back in the physical world. So this physical to digital to physical leap is the essence of Industry 4.0, is what I would like to stress upon. The main thing is here that while it plans to enhance this digital capabilities throughout the manufacturing and supply chain processes, it also brings with it cyber risks, for which the industry is not but underprepared. Now, developing a fully integrated strategic approach to cyber risk is fundamental to manufacturing value chains as they merge operational technology and IT, which forms the very force of driving the Industry 4.0 technologies. Now, when we talk about ubiquitous manufacturing, right, we have to examine what are the elements or what are the layers of this, right? So we see different elements here. And I see a question here. Yes, I'm coming to that. Right. So when there is a completely, spread out way of manufacturing where, you have a complete digitized operation from supply to factory to the objects, that is what we call ubiquitous manufacturing, right? Now, there are elements to it. Now, today we'll examine the modern, connected digital supply networks, smart factories, connected devices themselves, and see what are the cyber risks which are faced by each of these moving through the production life cycle, right? So the first thing that we talk about is the digital supply network, right? And then the digital supply network is nothing but the typical supply chain, which has now got evolved with the Industry 4.0 technologies to get into something called as a digital supply network. And then we have the smart factory itself. Of course, the connected objects within the factory, right? We'll take a deeper look at this as we go further individually into each thing. But this is the overall picture of how, ubiquitous manufacturing encompasses a digital supply network, a smart factory, and the connected object. So
can I ask a question here?
First, at the strategy.
Can I ask a question here?
Yes, please.
What is the meaning of the word ubiquitous? It's a very difficult English word. Can you please explain in the context of this topic today?
Okay, so see, ubiquitous means it is not in one place. It's not just local to one place or central to one place. It is all around. So there is no need for a physical action to take place. Everything can be digital.
You mean like a decentralized manufacturing in a supply chain? That is, it is present, vendors are present all over the country, that kind of thing?
Correct. Decentralized and digital.
Physical also decentralized, digital also decentralized. You mean to say that?
Yes.
Okay, I got it. So ubiquitous means the physical systems are spread all over. The data is also spread all over.
Correct.
Got it.
So there is no dependency on a single location presence.
So we are not looking at a server kind of a dependency.
Correct, yes.
Got it. Please proceed. Thank you.
Right. So when we talk about the security strategy, right, for any Industry 4.0 system, then we look at the three operative approaches. One is to be secure, the other is to be vigilant, and the third is to be resilient. Right. Now, Industry 4.0 brings with it a new operational risk of connected smart manufacturing and digital supply networks. that risk is cyber risk. Before this, it was always a physical risk in 2.0, to a greater extent in 3.0 also, because 3.0 has some element of cyber risk, but 4.0 there is a very increased element of cyber risk, right? The interconnected nature of these 4.0 driven operations and the pace of digital transformation that is happening means that cyber attacks can have far more extensive effects than the earlier versions or earlier revolutions. And again, the operative thing over here is that we feel that organizations are not adequately prepared for addressing these issues. Now, what is the meaning of being secure, being vigilant, and being resilient? So, by secure, to take a different analogy, right? If we have, let's say, if we have a godown, right, or a factory, so if we put up a proper compound and a gate and lock it up, that is secure. Now, just that might not be enough. So what we do is we put a security guard outside. Now that is vigilant, because that person's job is to keep monitoring and keep observing whether anyone is trying to penetrate or not. Now, the third part becomes more important in the sense that how much ever the philosophy here is that the law of averages, how much ever we prepare, there is bound to be an incident at some point of time. There is bound to be a security breach, or there is bound to be a threat which materializes at some point of time. Now, resilience will define how we respond to that and how we recover from that. The recovery part is, I think, the most important part, because how much ever we prepare, it is bound to happen at some point, and how soon we can recover from that is the most important aspect. So the macro strategy defines how to be secure, how to monitor and be vigilant, and at the same time to have a plan in place which keeps the organization ready to respond and recover from such an incident. So as I told earlier, we'll look at each phase in a very detailed manner, right? So let's first take the supply network. Now, what is this supply network, and how we look at the security aspects of this? So supply chain is fundamental to any manufacturing organization, right? Now, I'm sure most of the participants are from manufacturing industry, so you would agree to that. Now, it's very tightly connected to consumer demand, and many global organizations actually use demand forecasts to determine the quantity of materials necessary, the manufacturing line requirements, the distribution channel loads. Analytics have also become very sophisticated, so that today's organizations are able to utilize data and analytics to understand and predict customers' buying patterns and alter the production accordingly. Now, Industry 4.0 technologies, they are expected to prompt a further evolution in this traditional linear supply chain structure by introducing intelligence, connected platforms, and connected devices across the ecosystem. Right. So here we are talking about platforms and devices which are connected. So this will result in something called as a digital supply network, right? So that is where the DSN is. So when you have a supply chain that has evolved to have different platforms, the platforms could be, your ERP system. The platform could be a vendor management system or a vendor onboarding system. The platforms can be payment systems, right? So when all these are getting connected, that is where you are getting a completely digital supply network, right? Now, this would be capable of capturing data from points across the value chain and inform each other. So each platform would be able to talk to each other, and this will result in better management and better flow of materials and goods, and more efficient use of resources, and appropriately meet the customer needs. However, the same paradox continues. The increasing interconnectedness of the DSN also brings with it the the cyber weaknesses that should be properly planned and accounted for in every stage, from design through to operation, to prevent any risk that gets involved in this due to vulnerabilities. So what organizations need to do here is they'll first need to consider what data should be shared. So when we are talking about a digital network, so this network would have not just internal participants, but they'll have external people like suppliers, right? Now, for example, some suppliers in a particular DSN may be competitors in other areas, right? So you may not want to make certain types of data available to them because, it might then be to your own detriment. For example, pricing information or proprietary technology kind of things. There also might be regulations that are available. The suppliers may be subject to regulations about type of information that can be shared. So we have to be very careful about what data is to be shared. And most importantly, security is not just about technology. It's also about good hygiene of governance, security, data governance. And of course, there are other aspects like network segmentation, having intermediary systems which act as middlemen to protect and segregate sensitive data from day-to-day data. Here I'll take an example of other industries, because most of the time it's always better to learn from industries which have actually implemented such things successfully. For example, financial services, right? Now, financial services industry, they have this huge challenge because the data there is very sensitive. It's all financial transactions, financial information. So what they have done is they are leveraging tools such as encryption and tokenization. So encryption is for data at rest and tokenization is for data in transit. So whenever there is an interception that is happening or systems are compromised, the entire transaction is aborted. So that's how the whole security implementation for financial services has been done. Now the same can be replicated even in Industry 4.0 for digital supply transactions. One more very interesting, and I'm sure this one most of you would have heard, is the use of blockchain, right? So I'm sure is anyone not aware of what blockchain is or never heard of blockchain? Because nowadays
better to cover it as a specific point here in the context of cybersecurity. You might like to recap the concept of blockchain.
Okay. So the blockchain, I was kind of asking this because there's a lot of buzz around Bitcoin in the last couple of months. A lot of people wanting to know how to buy Bitcoin, how to invest in Bitcoin. So blockchain is an underlying technology which also does the same kind of things. But from an Industry 4.0 perspective, blockchain is used for a different purpose, right? Now, blockchain is used as a tool to determine. Just 1 minute. I'm sorry, I'm sorry. So blockchain in Industry 4.0 is used as a tool, to determine the flow of goods from production line through various layers of purchasers. Now, what blockchain does is it creates a historical ledger, right? Now, this ledger is shared across a community. It's not kept at a central place. If, for example, if you have a ledger which is stored in one place, then it's very easy for someone to modify the transaction information in that ledger to manipulate a transaction or to do some fraud kind of a thing. But imagine this: if a ledger is shared across multiple people in a community, which is not known to the person who's trying to attack the ledger. Now, that person or that actor might be able to alter it in one place. But then when reconciliation is done, that will mismatch with the ledger that is stored across various points in the community. and that would make the transaction to get discarded. So that is the very layman explanation of what blockchain does. So it creates a historical ledger of any transaction and stores it across different entities. It's not stored in a single entity. Now this approach, this tool of storing this historical ledger in Industry 4.0 can be used in different ways. One, as I told, is to determine the flow of goods across purchases, so that there is no adulteration, there is no theft and that kind of stuff. Logistics, for logistical purposes, for the movement of goods, it is used to track the movement across different warehouses. And most importantly, this is used to categorize products more specifically than the traditional methods of categorizing them in lots, batches, and so on and so forth, so that it becomes easier in case of recalls, defects, that kind of stuff. Now, so that was more about how blockchain can be used, and as we seek to do this implementation of all these practices, as I told earlier, we need to see how other sectors' approaches have been useful and how they have been successful in managing cyber risk. Now, again, one more example is the automated trading model in financial and energy corporations. So they trade, energy and this kind of stuff. So again, the same highly responsive methodology is used, which is very similar to what a DSN will do.
What is the main difference between data sharing and vendor processing?
Vendor processing, no, data sharing is sharing data across any system. ERP systems, it need not be just vendor, it could be internal, it could be across factories. So data sharing is a very broader and generic term. Whereas when we talk about vendor processing, we are talking about third-party systems, because when a vendor is onboarded, they might come with their own systems. So there has to be that integration done between an organization systems and the vendor's systems. So that could become a threat surface area where there can be vulnerabilities. Even vendor's due diligence, if it is not done, the vendor himself or the vendor would try to exploit any vulnerability that is existing in the system. So that is the reason vendor processing has a very different approach, wherein trust is maintained. So what it does is that whenever there is whenever the trust fails, or whenever the certificate or the token fails, that it fails to establish that it's a trusted request, then the entire process has to be safeguarded, because we are dealing with third-party systems. So data sharing, one way to look at it is data sharing is inside out, so that you safeguard your private proprietary data from external systems. And vendor processing is to ensure that external systems don't hit us. So it is outside in. So it is different directions.
Got it. Got it. Now it's more clear.
Yeah.
Okay.
So we'll move to the next one. So here we take about the next element of the ubiquitous production, that is the smart factory. So we have now covered the digital supply network. So we understand, what are the operative functions in that, and how it has to be safeguarded. Now we come to this. So just as adding connectivity to DSN introduced new risk vectors, so same thing happens to the smart factories, also smart manufacturing. Now here the risks increase and diversify, and they do it at an exponential rate, right? Now, for example, it's not hard to imagine a misused or a manipulated request for ad hoc production line can result in a financial loss, product quality issues, safety concerns for workers, right? So the worrying thing, or not the concerning thing here is that manufacturers are not prepared for these cyber risks for their connected and smart systems. So we are deploying smart systems. We are implementing a lot of connected initiatives to get into the Industry 4.0 technologies, but the audit and the assessment of security is not as much as it should be. Now, for example, a study was done by Deloitte, and it found that more than one-third manufacturers have never performed any cyber risk assessment of their industrial control systems, which are actually operating on their factory floors. So this kind of laxity in matching up security assessment with digitization is what is a bigger concern for Industry 4.0 when it comes to security. Right. So if you look at the threats, the threat sphere for industries, threats have always been existing, but these have been more physical in nature. If you look at from 1.0 to 2.0 to 4.0, the threats have existed and they are continuing to exist. What got added from 3.0 onwards is the cyber threat vector. Right now, from an operational perspective, these modern industrial control systems, they allow engineers to deploy unmanned sites while maintaining high efficiency and resource control. Now, this is done by using connected systems, by using ERP, SCADA. Now, these systems streamline the processes and make things easier, more efficient, and they have continued to evolve. Right. Now, what is happening, especially with 4.0, is there is something called as COTS. Right. So, of course, the system complexity goes up, but there is something called as the commercial off-the-shelf products. Now, as COTS products start getting implemented into the industry floor, the vulnerabilities go on increasing because these are commercial products. There is no customization, there is no custom security implemented. So a product that is taken off the shelf by an organization is also available off the shelf to an attacker to exploit, understand the vulnerabilities and use the same. Right. Now, if you see across, we are focusing on cyber threats now because physical threats is not something that we are going to cover. So across 3.0 and 4.0, if you look at the threat, the security related trend, right? So the number of potential cyber threats is going up. Now, this is the important part. Why is it going up? Is because the usage of COTS components is increasing, right? In 3.0, for a very large extent, we had a lot of custom logic that was built into the systems. Now, with industrial internet, we are using a lot of standard generic components, which bring in a lot of known vulnerabilities. So data exchange is higher, and of course, the process isolation is lower. So what happens is, while the basics of cyber attacks remain the same between 3.0 and 4.0, the way or the method of delivering attacks becomes advanced, right? So now this is a threat landscape, as we examine the factors that drive operational and developmental priorities of companies which are running manufacturing processes. We need to see the strategic imperatives and operational values which have to be identified, and the corresponding cybersecurity actions have to be implemented. So this map, it talks about, you see these the threat indicators. So you have got the threat motive, and then you have got the actor technique. Then you have got the attack surface and the cyber defense. So when we are talking about the strategic imperatives and the operational goals, right? Cyber defenses have to be built in at the core of this whole strategy and the goals, because there are different points at which the actors will have different motives and different techniques. But as an organization, the security imperatives have to be built into the design itself. If we look at the next one, so what are these functions and what is the associated security imperative for this. Now, for manufacturers, right, I would say that there are three strategic imperatives that drive the manufacturing mindset, which is the first one is health and safety. So it is like safety for the employees, the environment, the site, the health and safety imperative. Next is the production and process resilience and efficiency. It is critical to ensure, there is continuous production. There shouldn't be any loss or downtime in production. So because it reflects loss in money, it has a lot of, raw material loss and all those things. And the third imperative is the instrumentation and the proactive problem resolution. Now, this is more around, the protecting the brand and the reputation, because, we are talking here about problems. We are talking about issues that might be reported. So to protect the brand, there should be resolution. And therefore, the security categorizations also reflect that. So resilience is very important when it comes to resolution. Same thing, when you're talking about production, resilience is very important, right? Whereas health and safety, you have to be more vigilant because you have to prevent such a thing from happening in the first place. Because health and safety, if an incident occurs, recovery is fine, but then that incident itself has a very wide, significant impact, right? Now, that was the first priority. In the second case, what happens is, organizations, they need to respond to different operational values on a day-to-day business, right? So in that case, what happens is their main thing is systems operability, reliability, and integrity. So this is basically to reduce the cost of ownership, to ease the component replacement. It's all about reliability and integrity of their systems. And here again, it has to be secure and it has to be resilient. And of course, the regulatory due diligence is one of the most important aspects of any manufacturing process. So cybersecurity has to be built in at the design phase itself to make it very secure. Right. So now we come to the third part, which is the connected objects themselves. Right. Now, what happens is
Your bandwidth is not okay. Your voice is fluctuating. Maybe you can switch off your video.
Okay.
Video.
Just let me try that. Let me try that.
Let's have only the audio because.
Okay. So is it better now?
Yes, much better.
Okay. Right. So here we are talking about the connected objects itself. So we covered the supply network, we covered the smart factory. Now we are talking about the objects, the products that are having, or the devices that are present. So here we have to see a couple of things. One is, when we talk about connected objects, these could be the smart machines themselves that are connected on the floor, wherein you're getting a lot of data and taking actions and analytics and so on and so forth. The other aspect is the manufactured products themselves. So there could be a product that is manufactured by the organization which also is having connected capabilities, right? Now, what happens is the security has to be so hardened that even when this connected object goes out to a customer's place, it is still going to talk back to its production or the mother organization. There is a possibility that this connected object or the object which actually went out can cause a security incident if the security is not taken care of, right? So that is how objects security is to be looked at. If we look at the scale of this, right, now we are talking about everything, not just industrial, but overall. 10 years back, I think it was, that Ericsson came up with this statement, which was around 20 billion connected devices. Right, so that was the kind of scale that was being perceived when M2M or the IoT industry was in its nascent stages. And then that figure got revised to 50 billion devices. Now I don't know whether it is in that 100 billion range or what, but that is the scale of connected devices that we are going to see worldwide. Now, these devices, they might be B2B devices, they might be industrial devices, or they might be B2C devices. But end of the day, all of these connect back to some organization or the other, right? And these devices can be used to attack and bring in a DOS kind of a scenario, a denial of service, to another organization. So just because a device is manufactured and sent out, our security imperative doesn't end over there, because the device is likely to go out into the field and still remain connected. Is my screen visible?
Yes, sir.
We are able to see your screen called security categorization and objectives.
Okay. Let me just, because I
For
lost my
connected
screen.
objects. For connected objects.
Yes.
That is slide number 19.
Right. Okay. Just let me know if. Okay, so just let me know if the screen is not visible, right? I'll continue.
Visible, visible.
Yeah. So here we were talking about, the connected object, not just concerned about the security till it is within the organization, but even after it leaves the organization, the integrity and the security of the object, the imperative lies to a part with the manufacturer also, because that object is capable of disrupting the manufacturer's operations. Now, how this happens is it has actually happened in the past, where we have got something called as a botnet. So the attacker takes over these devices and then makes these devices send very large amounts of data back to the server, to such an extent that the server crashes. Now, that is called a botnet attack. Right. So that is why, connected objects, the security of this connected object, it extends beyond the organization's boundaries. Now, what exactly can we do over here to, make these connected objects more secure? One is the product design. Now, when we are talking about product design, right, we should be talking about something called as SSDLC. So I'm sure most of you would be aware of the term SDLC, the software development lifecycle, right? So we add another S and make it secure software development lifecycle. So how software development lifecycle has got checks and gates at each stage of the software development to test for the quality of the software and adherence to requirements, right? So typically what happens in software development lifecycle is that after each phase, there is a check performed to see whether the software that is being developed is as per the requirements and as per the quality. But what is never assessed is whether it is secure, right? So here we are talking about a newer kind of SDLC, where we are talking about secure software development. So there should be a check at every phase whether security principles, whether have been implemented or not, whether there are vulnerabilities, whether there are any places where someone can easily exploit those to create an incident. The other part is something called as the attack surface reduction. Now, it is again linked to the SSDLC itself. So basically, what is an attack surface, right? Now, the attack surface is basically the points, the various points through which an attacker can gain access, right? The more number of such vulnerabilities, the easier for the attacker to gain access. So how it happens is, to explain it in a standard format, is the more flexible we make a system, right? The more and more we expose the internals for an attacker to gain access. So it is kind of a dichotomy. To make it really secure, we have to make it really hardened. So a hardened system is very inflexible. So you won't have a lot of options to do customizations. You don't have a lot of features, but it would be very secure. The moment you open up a system for flexibility, customization, and so on and so forth, then at the same time, we are creating those surface, or we are increasing the attack surface to give an attacker points to access and enter the system. So that is how attack surface is judged. And it's always, when we are doing device development or product design, the main focus has to be to optimize and reduce the attack surface as much as possible. Right. The third thing over here that we have to understand is the design paradox, or sorry, the update paradox. Right. Now, the update paradox is called a paradox because, one, for a system to not get shut down due to a security threat or some malfunction or something, we need to keep updating the system. But in order to update the system, many times you have to cause a shutdown to the system. So that's why it is called a paradox, that you have to do something which you are doing to not do that thing. So you have to shut down the system to ensure that it doesn't shut down, right? And that is why a lot of these systems in major organizations are never updated. Because when you have to update, you have to bring down the system. There is a system downtime, there is a production downtime, there is a wastage of raw materials, and so on and so forth. And the other part of this paradox is that whenever an organization is deploying these devices on the factory floor, the expectation is that these will run for at least 10 to 20 years, without any breakdown or something like that. Now, typically, any device or any object that runs on software cannot sustain 10 to 20 years without an update, because the the threats keep evolving. So in order to meet those threats and counter those threats, the software also needs to keep getting developed. And that is how updates come into the picture, right? So there can't be a device which can run without any update for 10 to 20 years. And that is the challenge over here, where we have to have a product design, a device which can be resilient and really secure over a larger period of time without needing frequent updates. So that is, I think, the crux of how to bring in security into the secured objects thing. Of course, there are other things also, that is, leveraging AI. Now, there have been a lot of, I would say, initiatives. There was even a competition held to see how AI can be leveraged to sense, scan, and rectify a security incident without any human intervention. So how it does is that AI could be designed to keep sensing, then it understands a security incident has happened, it analyzes how that security incident happened, and it automatically develops a patch that prevents that from happening. So that is the kind of AI platform that is being looked at. The Department of Advanced Project Research, the DARPA, is kind of heading that kind of initiative to leverage AI in securing objects, right? And another very important aspect
So you are
is
in which slide now? So far, you are in which slide?
The same security categorization.
Slide number 19, is it?
Yes.
Okay.
So
Okay.
data protection, product design.
Yeah. Connected objects.
Correct. Connected objects.
Okay. Since you asked, the slide is moving. Okay. Please go ahead.
Yeah. Right. So one final point about securing this connected objects is protecting the data from the devices themselves. Now, what do we mean by that? Right? We have a lot of these devices which are sending out data. Now, most of the times, majority of the times, the data is sent out in a raw format. Right? The data is not just analogous sensor data, but many times it's also proprietary information that is being sent out. There is a lot of sensitive data that is being sent out, and it is sent out in an unencrypted form. So then what happens is, any one sniffing onto that network can take in raw packets of data and straight away use it. Now, that also is a principle that needs to be done at the product design itself, that any data at rest within the device or any data in transit has to be encrypted. So it has to be secure. Right. So those are the kind of security imperatives that are needed for connected objects. Then we move to I didn't have any other title, so I used RRR, which is kind of in vogue nowadays because of the movie, but this is for a different reason. This RRR is for something else, which we call it as readiness, response, and recovery. Right. Now, as I mentioned earlier, right, the need to be secure and the need to be vigilant, right, is important, because being secure makes the system secure, so that the systems are safeguarded. The systems are having all the protocols in place where they are going to prevent a security incident from happening to the best of the knowledge. Being vigilant ensures that there is a constant monitoring of the network, of the systems, of the devices, to see if any intervention is taking place or any changes happening to their state. But as I told, whatever be the security protocols we put in place, the possibility of an incident happening at some point of time is inevitable, right? And this is where these three R's come into the place. Now, when we talk about resilience, right, the resilience of a system, for the system to be resilient, right? Now, these three R's have to be in place. These three will go together to make a system resilient. That is, there has to be readiness, right? An organization should be well prepared to efficiently deal with aspects of an incident. So there should be clearly defined roles, responsibilities, and actions that have been identified whenever an incident occurs. There should be simulations done. Wargaming exercises, there should be such simulations to see how people react, how people respond to such an incident, so that gaps can be identified and it can be remediated before an actual incident happens. An example I can say is that from a very IT experiences, that an organization actually simulates phishing emails to its employees. So they send their own employees emails which actually are for phishing, where you click and it will cause some harmful thing, kind of a thing. It's just a simulation. And they see whether the employees actually report that phishing or they click on the email. And then, those employees are sent feedback saying that, congratulations, you prevented a phishing attack. Or they said that, no, you've clicked on a phishing and potentially, threatful incident. So that is a kind of simulation that is very important, even in industries, to keep everyone ready and also to identify any gaps in the readiness. The next one is how the organization responds to an incident. So being ready for an incident is one aspect. Next aspect is responding to that, right? So the response also should be planned, communicated, so that everyone throughout the organization is aware of how a response should be should an incident occur. Right? And the third and a very important aspect is recovery. So how do we return back to normal operations? So whenever an incident has occurred, once it has occurred, it's a post-event. There is nothing that can be done about the event itself, but there should be an immediate focus on how to get back to normal operations and limit the damage of that incident. There can always be post-event analysis about, incorporating lessons and those things. But this whole recovery process is more centered around how to get back to normal operations. Right? So that's why we say that, a resilient organization should minimize the effects of an incident while quickly restoring operations and security. So in conclusion, we should take measured, risk-based approach to what is secured, how to secure it, and see whether our intellectual property is safe, is the supply chain or the industrial control system environment vulnerable. So these are the things that go a long way in making us secure. The next aspect is to see how we can continually monitor systems, networks, devices, personnel, and the environment for possible threats. Real-time threat intelligence and AI are often required to understand harmful actions to quickly identify threats across the multitude of connected devices. Now, this whole action is around being vigilant. And when the incident happens, how should the organization respond? How long will it take to recover? And how quickly can we remediate the effects of an incident? Now, this is what makes us a resilient organization. So when we talk about ubiquitous security, we are talking about being secure, being vigilant, and being resilient across all the elements of a ubiquitous production. So I think that would conclude my content for today. And I hope I'm within the time Mr. Mowgli allotted me.
No, you are well within the time. Thank you very much, Mr. Mustafa. Very, very detailed technology session with a lot of explanations. Now that we finished earlier, we can take up questions where there are only 20 participants. They can click the hand, raise the hand. They can even open their audio and ask the question. Rupa can enable all the people's audio.
I have done, sir.
Maybe video. And Mr. Shivaram wants to ask a question about 2011 versus 2022. Go ahead, Mr. Shivaram. Mr. Shivaram? M.R. Shivaram? Gone for coffee? Yes, Mr. Shivaram, go ahead and ask your question with your audio about 2011 versus 2022. What is the question? Shivaram, you have to switch on your audio. Rupa, is audio permitted?
Yes, sir. I have enabled both audio and video, sir.
But they have to again click the audio, right?
Yes, sir.
Shivaram, you have to click the audio.
Am I audible now?
Now only you are audible. So all of you want to ask question.
Yeah, my question was in the slides I saw this 4.0 was dated as 2011. So now we are in 2022. I just wanted to why it is still called as 4.0 when we have passed all the 10 years from now, then and now. That was my question.
Over to Mr. Mustafa.
Is your question related to this slide?
I'm not able to see the slide. Now that in one of the slides, sir, you said you gave the time periods, like, earlier period, how it was in 2002, 2009, like that. And in 2011, it said today you're talking about 4.0. But we are in 2022, why it is still called as 4.0? That was my question. Nothing important, but just a...
Mustafa?
I'm just trying to see which slide that was.
Anyway, it
Just
doesn't
give
matter.
me-
It's quite an
Yeah.
academic question. Let me take this question, Mr. Shivaram. Are you a professor or are you from industry?
Industry, sir.
Very good. Are you MSME industry or large industry?
MSME.
Okay, sir. Good. See, the periods of previous periods run into 100 years, 60 years, 30 years, etc. The period is shrinking, if you notice. The mechanical revolution was more than 100 years. Electrical revolution was probably another 100 years. Then electronics and computer science was 60 years. Now this revolution started in 2011. That revolution will take time to adapt. Only the Western world, like America and Europe, have adapted this in a large way. Indians, large companies have done it. Tata Motor, Toyota and all adapted it. MSMEs are still waiting to open their purse. So the adaptation will take time. So 2011 it starts. There's no hard and fast, it has to run for a decade, 2022. So we have to get a 5.0. It's nothing like that. It depends on what technology drives the change. The first technology driven by mechanical engineering. Second technology, electrical engineering. Third technology, computer engineering. Fourth technology, internet-enabled systems, data-enabled system, digital revolution. So one more thing will come later. How does it matter? Are we adapting it today? Or the MSMEs like Mr. Shivaram ready to adapt it? That we should worry about. And once you adopt, the question from Mr. Mustafa is, are we secure, are we vigilant, and are we resilient? In fact, Rashmi Tirupati asked the next question. Before that, I want to ask Mr. Mustafa. Mr. Mustafa, you can come on the video. A question from my side. Then we'll go to Rashmi Tripathi. Others also can put the hands raised. Mr. Mustafa, your video. The question to Mr. Mustafa is, in the connected objects versus smart factory versus larger supply chain, there are different levels of security and vigilance that you require. Correct, Mustafa? That's what I understand.
Yeah.
You can have the video on. So you and me on the video. Only you and me in the video. Yeah, Rupa can guide us how to do that. So I'm interested in knowing the biggest supply chain security challenge in the wider area network. Let's say in a complete supply chain, when somebody attacks, are we ready as India to manage a complete network of Industry 4.0 across the supply chain, including the OEM, Tier 1, Tier 2, Tier 3, and job shops? This is how the automobile industry is organized. Automobile industry is organized under stages of supply chain. A truck is produced by, let's say, Tata Motor. And then the gearbox is produced by, let's say, Sundaram Clayton. And then the gears, inside the gears are produced by, let's say, Forging in Coimbatore. And the gear blanks are produced by some steel industry. So like that supply chain is literally a chain. And then network is happening because many players are there in every stage. Is India ready for a cyber security attack on such a supply chain wide Industry 4.0 implementation? Mr. Mustafa?
See, I won't be able to say as India, as a country, we are ready for it, because when we are talking about wider area network, we are talking about private organizations which are spread multinationally. Right.
So I'm saying, let's say there is a OEM making a truck manufacturer.
Correct.
The legal entity doesn't matter. It could be an MNC, it could be an Indian company, doesn't matter. And that OEM truck manufacturer has got several suppliers of assemblies, sub-assemblies, engine assembly, gearbox assembly. They call it tier 1. And the tier 1 has got several suppliers of the component parts. We call it tier 2. And then the component parts are further given to smaller job shops. We call it tier 3. So let us say this is the structure of a supply chain in an automobile industry. As a country, are we ready for cyber attack on a supply chain wide industry 4.0? Is there any country ready? Let's say America or Europe. Can we draw some lessons from that? You have any experience on that topic?
Yeah. So, the short answer would be no. Because, readiness is a very subjective term. But I don't think we are alone in that as well. Because, security incidents have been happening across the globe. If you see the map that I showed earlier, most of those security incidents were happening in the US, right? There are security incidents that have happened in Europe. So there is no specific example that I can say that, yes, this country or this geography is completely ready for Industry 4.0 in terms of security. Because security is a very evolving need. If someone is ready for today's challenges, the actors would also be working to come up with a new challenge tomorrow. But looking at the other part of the question that you said, in terms of tiers of supply chain, we are very, very back when it comes to even the audit itself. Being ready is one aspect. Even knowing that, we have these gaps, we do not have that. We do not have the processes in place where the tier 3, tier 4 guys, the MSMEs, are even thinking about security.
Got it.
The T1 people or the T1 organizations would have certain plans and certain protocols in place for security. But as they percolate down the supply chain, the complete focus is on just delivery. There is no even assessment done on the security aspects.
So it's very clear that should be the primary objective of the Government of India and the various private players before spreading the Industry 4.0 at a MSME level also. Very clear.
Exactly. Yeah.
Thank you. Thank you for that explanation. Rashmi Tripathi, can you go ahead and ask your question?
Thank you, sir. Good afternoon. Actually, my question is a little bit similar to your question only, because in OEMs and tier 1s, they have big infrastructures. They can take some efforts and measure some impact also for measuring these security levels. But if we implement IoT on small scale industries, they are starting also implementing this. But what measures you will suggest they have to take care for security level?
See, when we talk about IoT in MSMEs, right, as I mentioned earlier, IoT in MSME would be completely a COTS-based IoT. So they are going to purchase either commercial off-the-shelf products and components, or they have the option of going for a service model, where they purchase a cloud-based service from a service provider. Now, for MSMEs, especially the smaller players, I would recommend to start off with a service model, because there the cost of implementing security lies with the service provider and not the MSME. So what happens is, even though there might be a minor markup in the cost of implementing IoT solutions for MSMEs, but from a security standpoint, they make a very big gain that they have a complete secure infrastructure at their disposal, whereas by just using some off-the-shelf products, they completely miss out on the security aspect of it.
So, as per your opinion, that means small scale industry have to start IoT with some service provider. But how can we check that service provider is enough sufficient from security point of view?
That is where you have to do the due diligence. right? And these are the questions that, are very important that you need to ask the service provider to talk about, what kind of standards they are maintaining in terms of their security, whether it is infrastructure security, whether it is data security, information security, what kind of cloud they are using. For example, if a service provider is using, let's say, Amazon cloud, you would know for sure what are the security protocols in place in Amazon compared to some locally available, server space operator.
Okay.
So those are the kind of differentiators which would give you better idea of, sorry?
So a follow-up question, Mustafa ji, is that such a checklist of auditing, is it available in the public space as to what kind of questions should be asked by the service provider to the service provider by the client? Conversely, to audit a client, like ISO 9000 kind of thing, do you have a cyber security checklist available?
See, as far as I know, that for security per se, there is again a standard, I think it is BS 7799. So that kind of takes care of the information security and the data security. We also have, when it comes to data security, there is a lot of focus around GDPR. But GDPR is again Europe-centric and not India-centric.
There is privacy, right?
Correct, yeah. So again, privacy. That is data security. But when it comes to a checklist, sorry?
Cyber security, is it different from security in general?
No, cyber security would, encompass a lot of security elements. So when you say cyber security, it is information, it is data, it is network, all kinds of, connected security items come into it.
So
but again, coming to your question of a checklist.
Checklist, meaning how to audit. Suppose Rashmi Tripathi wants to audit her own company or with respect to a supplier offering. The questions to be asked should be very documented, because now from 2011 onwards, Industry 4.0 exists. Security issues exist from, let's say, 1980s, as you mentioned, from the very first ransomware, etc. So 1989, as you mentioned. So lot of literature would have been developed by the cybersecurity specialists. And if such a thing is available, then, or there are consultants who help them out, because anything has to be specialization oriented, is my follow-up question
Right.
on the question asked by, because MSMEs cannot afford to have, expensive consultants, but if they have a checklist, they can at least ask the questions.
Right. What you're saying is very important in terms of MSMEs and the availability of information, because consultants again would not be so easily available. But unfortunately, there is no single checklist that is available, right? Because it is a very subjective matter. Like the requirements would differ and change from organization to organization, and therefore, there can't be a standardized checklist. But there could be certain elements that have to be looked into in terms of the infrastructure, in terms of what data is being collected, what data is being provided, how the access is being given.
Okay. Okay, that is that point. Hello.
Yeah.
Mr. Viresh Sunkard.
Yeah.
Are you a professor or an industry person?
No, I'm an industry person.
Yes, sir. Go ahead, sir.
Yeah, we provide this consultation, or this. We actually come from the information technology background for manufacturing, non-IT sector specifically. And like you said, there is a challenge. In spite of giving a checklist, they wouldn't have the wherewithal to manage that, because it requires some understanding and it's subjective also. So we do provide certain support in that aspect of this one. So anybody is interested, we'll be willing to support in that area as well. For SMEs, like specifically SMEs, because like you said, supply chain, the tier 1, tier 2 companies have the wherewithal to do it. The tier 2, tier 3, tier 4 don't have it, and we are supporting tier 3, 4 to put these things in place, because there's a mandate from the tier 1 and tier 2 companies to do that.
Very good, sir. You can type out your email address and phone number in that chat box.
Okay.
And your company name. And I hope you are already a BCIC member.
I'm not a BCIC member, but I'm aware of the activities that are going on and wanting to support. So I'll go on to become a member also. Thank you.
Because BCIC will support your mission. If you become a member, I'm not canvassing for membership. I'm just.
No, I understood. Yes, definitely. I think we should use the platform to actually make it possible, because yes, there is a challenge and we can address the challenge and do what is possible.
No problem. No problem. So, Mr. Tamil interpreter, if you can declare who you are and which institute you belong to, then I can allow you to ask the question.
Hello. Sorry, one of are you able to listen to, are you able to
we are able
yes,
to
we can listen.
We can listen, but you have to mention your name, your institution name, your company name, then ask the question.
My name is Srinivasan Venkataraman. I am an IT professional, but I also do Tamil language interpreting, and in one of the teams, one I used the name Tamil interpreter so that the professional can identify me. I forgot to change it to my name. My apologies. Okay, there is a company called MV Technologies in Chennai. I am part of that organization.
Go ahead with the question. Now that you identified yourself, go ahead with the question.
The thing is, there had been, sort of IT. I am aware of Information Systems Audit and Control Association in US, etc. There had been IT audit guidelines. So my question was whether on the cyber security and other thing, any standards are being developed by any statutory body either in India or overseas, and if so, whether those, how to apply those guidelines, or whether BCIC would sort of be provide a focal point to develop the standards. That is the question.
That's a very good question. Mustafaji can answer that.
Yeah. So, see, when it comes to standards and audits that are recommended, we have something called as ISO 27000, ISO 27001, 27002. Now, along with that, we have BS 7799. So I'm aware of these two standards, which are predominantly used for information security, IT security, and audits. Right. Other than that, I'm not sure for any industry 4.0 specific standards that are being developed. Right. Because end of the day, security is around information, data, and such things. So it doesn't matter which industry it is getting applied to.
Thank you.
I hope, yeah.
Okay, I'm posting that link, what just now Mustafaji mentioned, and he is right. It includes all data security issues, including cyber security. 27007 ISO 9 standards, IEC standards. I have sent the link to all of you, and it contains all types of security, including cyber security. I just located it. Next question, please. There is also feedback from administration. You all can download it and fill up later and mail it back. Any other question from anybody else? I have a couple of questions, Mustafa. Can I ask?
Yeah, please go ahead.
Okay. The first question I have is, what is the major difference between cybersecurity at the cloud level and cybersecurity at the fog level and cybersecurity at the edge level? I remember your first graph, beautiful graph, and then from the mainframe computer onwards, maybe you can show the graph for the benefit of all. Can you please go back to the first graph? from mainframe computing
I'm just
going up to
trying
edge
to-
computing. Edge computing. Slide 4 or something. Very nice. The evolution graphs are very, very informative. Very difficult to understand though, because time was not enough for explaining. For example, that one, the previous one. No, sir. This one. Stay with the slide 4. You see the mainframe computer, 1955.
Yeah.
From that time, we have been having security problems. And then cloud computing, and then fog computing and edge computing. So it's happening like that. And the arrow is going up and down. I don't know. Up and down means centralization and decentralization. So
Correct.
as we decentralize from cloud computing to fog computing to edge computing, what are the differential challenges of cybersecurity? If you can throw some light on it, maybe a couple of sentences under each category: cloud, fog, and edge.
Right. So, let me first, give a basic my own understanding of this. So, how it happens is that we have cloud, right, and we have edge. So, let us visualize what is fog, right? When cloud touches the ground, it
Maybe you
becomes
should
fog.
explain for the audience the difference between cloud, fog, and edge also.
Right. So that's what I'm trying to talk about here. So, edge is on the ground. So edge is where, for example, if we take a factory, a smart factory with connected machines. So the data from the machines is there on the ground till it reaches the edge. From the edge, it is sent into the cloud. Right. Now, so that very clearly tells us what is edge and what is cloud.
Just hold on. I will elaborate this by illustrating CNC machine tool. CNC machine tool has got a CNC controller, and the data is coming from sensors. So would you say, Mustafa, that the some sensors also able to compute? I'm told vibration sensor, thermal sensor, flow sensors, they're also able to compute. Would you say those sensors which are computing is like edge computing, and the CNC controller is like a fog computing? Would you say that?
Could be. So what I'm coming to fog right now, right? I'm first creating the differentiation between edge and cloud, right? So for us, edge was at the ground, on the factory floor, where sensors are having data coming in or sending out the data, and you have a device which acts as a gateway. That is the edge. So it acts as a boundary between the ground and the cloud, right? And that was the edge computing and the cloud computing. Now, what happens is cloud becomes, again, very centralized. And a lot of processing is there in the cloud. And many times what happens is the processing in cloud is more expensive. Whereas there is processing power available on the ground, which is idle. So when you have a microcontroller, which is running at 20% capacity, you have got a lot of spare capacity of a processor, which is just idle. Whereas if you are having applications in the cloud, where the processing power is dynamically used based on the requirements and charged accordingly, it becomes more expensive. So what then happened is there was an idea to bring the cloud to the ground. So typically, when the cloud comes to the ground, it becomes fog. So that's how the term fog computing came in. So you actually try to bring the cloud as close to the ground as possible. That means you are bringing the computing, a very significant amount of computing at the edge itself. Right. So in fog computing, what happens is you have got thick fog and thin fog. So depending on the amount of computing that happens at the sensor level, at the gateway level, before it is put onto the cloud, that is where the fog comes in. Now, there would be a question or a doubt that, whether fog is going to replace cloud. So no, fog is not going to replace cloud. Cloud still remains. So, your storage, your applications still run in the cloud. But what we do is we optimize the processing that is done so that, the entire processing is done at the gate level, at the gateway level, at the edge level, at the client level itself. So try to make fog as thick as possible so that your cost on the cloud is less. Now it is just a trade-off of how much you want to spend on the cloud and how much you want to spend on the edge.
Apart from the cost, the quality and the speed of response, would you say is faster at edge than fog,
Yes, yes.
which is again than cloud?
Yes, yes, there is a significant change.
In
there is a
quality
very significant difference. Yes, when it comes to communication, speed is directly proportional to the quality. The faster the communication completes,
very good point.
The faster a communication completes, the better is the quality of the packet of data.
Very good.
Or the more number of hops it takes, there is a more chance of its degradation. Right. So of course, yes, the quality and the speed is much faster in fog than in pure edge and cloud combination.
Oh, you mean fog is faster than edge?
No, I'm telling just edge and cloud would not be as fast as
okay. Edge plus cloud compared with fog plus cloud. Okay.
Yes.
Got it. Which means by definition, the closer you're computing to the device on the shop floor, it will be faster in terms of latency effect. Yeah, you'll get a real-time benefit.
Correct.
The so-called real-time.
Yeah.
The dynamism in the way the data is processed in real time is always better closer you are to the device, correct?
Correct.
In other words, if I'm having a smartphone, I can do things faster on the smartphone as compared to waiting for cloud to give me the feedback through my Wi-Fi or Google server or whatever. Yeah. Similarly,
yes,
even a smartphone of an operator, a shop floor operator having a smartphone is also a device in the smart factory. Correct or not?
Yes.
So now coming to cyber security, what will be the differential aspects between cloud computing cyber security, fog computing cyber security, and edge computing cyber security in terms of your own three criteria? If I do a 3x3 matrix, it will be very interesting. You can publish a paper on that, Mustafaji. Is cloud, fog, and edge on the row, and your what is called the security, vigilance, and resilience and the column. If you can put this together, and inside the boxes, we get all the various softwares, security softwares and other devices available, and also the threats, various threats available. This will be very useful for the factories.
Yes,
but a few thoughts from your side.
It's a very good idea to do it.
Few thoughts you can share on cloud, fog, and edge vis-a-vis these three parameters. A rough brainstorming.
Right. So now, see, the fundamental difference over here is the control. Now, the cloud is controlled by very large tier 1 organizations who have the resources to invest in, the best-in-class security protocols.
Okay.
Now,
like
for example,
Amazon.
if you take AWS, Amazon or Google or Azure, Microsoft Cloud. So these are all clouds which have got, investments in millions and hundreds of millions to make these secure. So they have all these components of security. They are secure, they are vigilant, and they are resilient. So there are instances where there are outages in the cloud, but then those outages get rectified in matters of seconds. So if your server on a AWS instance, if you are using an EC2 instance on AWS, if that instance goes down, it doesn't take a long time for the instance to come back up. So the resilience is very much built into this system. Now, as we move down from there, as we move closer to Earth, right, the decentralization starts happening. Then it is a subject matter of which device is being used in the fog, which device is used at the edge, to understand what are the protocols built into that device, because that is no longer in the control of the cloud operator now. Right? Now, the fog device or the edge device could be a very well-reputed brand which has invested a lot in building in those resilience protocols, or it could be just some basic functionality device which is doing some bare minimum functions and which is not capable of recovering from a crash without some intervention or some update. So as we come more towards decentralization, security becomes more challenging.
Okay.
Right.
It is also challenging because it is in multiple points. It is distributed.
Yes. And not
over
all are
space.
uniform.
Correct.
Yeah, I
So
think since it's a brainstorming, I would like to add as a one that
yes,
when
sir.
there is a bigger company, the challenge is the security features are there. We need to be aware and ask them to it and be aware of the cost, because it comes at a cost and we should be ask them for that because all those features are there. At this level, the features may or may not be there. We should be aware again and demand for it. In the sense, like you said about the brand of the product and those things, any security is only as good as the person who configure it or the people who configure it. So we need to actually ask them for that security feature to be enabled on the business. So that's one of the things we should take care.
No, at the same time, the sensor manufacturers and PLC and control manufacturers are diversely present across the world.
Yeah.
And nowadays, people brag about sensors becoming cheaper. I'm worried. As the sensors are becoming cheaper, are they more reliable or less reliable in terms of cyber security? It's a moot point. I don't want to debate that. I will leave it to Arnab Goswami to come on the dais to debate that on the lighter vein. And with the rest of the 3 minutes available to us, I think a good diverse participation today. And Mr. Mustafa ji, with your permission, we are going to post this video on the YouTube of the BCIC. So there are around 60 people who registered who could not join today. They all can listen to it. And more people also could listen. There are 800 members of Bangalore Chamber of Industry and Commerce. And Rupa ji would like to make a note of people like Mr. Viresh Sunkard and all to contact them to become members if they are interested. And the various professors and students listening today, I hope you had something to take away from this presentation. I also had many jargons written in this presentation, and I request Mustafa ji to provide a glossary of it. For example, I wrote in the beginning, what is WWW, what is P2P, what is SOA, layman like me, we don't understand. Many students are also here. Mustafa ji has flashed his email address, phone number there. And what is WWW, Mustafa? What is P2P?
It's World Wide Web.
Sorry?
P2P is peer-to-peer.
Peer-to-peer. Example is?
Yeah. I gave you an example of that torrent, right? We used to download the pirated movies using torrent some 10, 15 years back. So we had these clients called BitTorrent client, MuTorrent. So they connected one computer to another computer directly without a server or a network in between.
Oh, okay. What is WWW?
That is the World Wide Web.
Okay. What is SOA?
That is one of the flavors of the internet.
Correct.
SOA is,
okay.
Yeah, SOA is something called as service-oriented architecture.
Got it.
So
I think
we use services, we use APIs.
It will be very helpful to have a glossary for the students who are joining today. And such abbreviations can be expanded. But each one of your slide had so much of content. Obviously, in a 1.5 hour session, it's very difficult to cover. And thank you very much, Mr. Syed Mustafa. And thank you all the participants who have joined. It's 1 o'clock now, time for closing. And thank you, Rupa and Bangalore Chamber of Commerce to host this session. We will bother Mr. Mustafa again and again for other projects. And I believe you are also very good in service sector related knowledge base. So at a later date, Rupa will contact you for a program on service sector digitalization. You can give us some use cases, and maybe you can bring in a couple of more experts to have a nice panel discussion. Sometime, in a 1.5 hours, if there are 3 experts and you can moderate them, apart from being one of the speakers, if there are 2 more experts, it gives a nice diverse flavor to a topic like service sector. For example, one panelist can talk about healthcare sector, one panelist can talk about telecom sector, one panelist can talk about logistics sector. I'm just giving example. Or a food and beverage sector, anything in under service sector, and you can be one of the speaker and coordinate the other 3 with your contacts and make a nice panel discussion on service sector. Maybe we will disturb you again in the month of July or August for such a possibility. And then if you can think through it, and then Rupa will contact you. It is a fantastic session. I learned a little bit on cyber security today. The takeaways are very clear. We have to be worried about security. We have to worry about vigilance. And we have to worry about resilience. All 3 look similar, but there are subtle difference between the 2. When I was going through literature the other day, I found privacy and confidentiality. I got 2 different meanings. Yeah. So these are all the jargons. Privacy means different. Confidentiality means different. Yeah. And we have to be careful. Data security, cyber security. they can be different. Cloud, edge, fog. So by understanding the compare and contrast, our knowledge improves. Thank you very much, BCIC, for this platform. And thank you, Mr. Mustafa, for joining today. And I request everybody to give a big clap. Maybe they all can come on the gallery and Rupa will take a photograph of the gallery. Mustafa, you can close your slide. And normally we'll go to the gallery and Rupa will take a photograph. That means I'm expecting all to open a video. Gallery means there should be a video. Open the videos regardless of. Okay, if you feel shy, you don't have to open. But those who want to open the videos, that is, the speaker has opened. Mr. Viresh has opened. He's a potential customer to Rupa, Mr. Shivaram, and others. And Rupa, you can close it with some kind of a photograph. Yeah, normally they have a monthly magazine called Synergy, and they publish all these things. So it will be good to have all of us going to the together mode in the photography.
Cool.
Together mode. When I did together mode, it looks like a gallery of a mountain and Krasta ji has joined. Mr. Krasta. Oh, pray. He is a true doyen of MSMEs. And thank you, sir. And Krasta ji, I hope it was interesting. And I think cyber security is very important in your environmental chambers, which you develop for various applications. Mr. Joseph Krasta is a BCIC doyen MC member, and he represents several chambers in the country, nationally and regionally. And I can see him sitting under the tree in my gallery. Thank you very much, Rupa. Bye-bye to all.
Thank you. Good day.
Thank you very much.
Wonderful session. We really enjoyed it.